Good morning. Today we are going to see the Earth eclipse of satellite and also transit outage. It occurs when Earth's equatorial plane coincides with the plane of the Earth's orbit around the Sun near the time of spring and autumnal equinoxes. When the Sun is crossing the equator, the satellite passes into its shadow at certain period. Geostationary satellites would be eclipsed by the Earth once each day, as equatorial plane is tilted at an angle of 23.4 degree to the elliptic plane, keeps the satellite in full view of the Sun for most days of the year. The figure shows the Earth eclipse of satellite. Around the spring and autumnal equinoxes, when the Sun is crossing the equator, the satellite passes into its shadow at certain periods. These being period of eclipse. Spring equinox is the first day of spring. Autumnal equinox is the first day of autumn. Eclipse being 23 days before equinox and end 23 days after equinox. Causes of eclipse. During full eclipse, satellite receives no power from solar array and relies only on batteries. Reduction on primary power reduces satellite life. During eclipse, it is necessary to shut down some transponders and results in reduction of satellite performance. Solar fluctuation may cause failure of primary power system. Severe thermal stress on the satellite. When the satellite longitude is east of ES, the satellite enters eclipse during daylight. This is undesirable if the satellite has to operate on reduced battery power. When the satellite longitude is west of ES, the eclipse does not occur until the Earth station is in darkness when the usage is low. Hence, satellite west of ES is more desirable. Probability of satellite failure is more during eclipse than at any other time. Then we'll see what is subsatellite point. The point on the Earth vertically under the satellite is referred to as subsatellite point. The latitude and longitude of the subsatellite point and height of the satellite above the subsatellite point can be determined from the radius vector r. This is the geometry for determining the subsatellite point. The height of the terrain above the reference ellipsoid at the subsatellite point is denoted by HSS. The height of the satellite above this by HSS. Thus, total height above the reference ellipsoid is small h equal to HSS plus small hss. Then, Sun transit outage. Another event which occurs during equinoxes is the transit of the satellite between Earth and Sun. Sun, which is powerful broadband microwave noise source, passes directly behind the satellite, and the receiver with the beam directed towards the satellite picks up both the satellite signal and noise from the Sun, which completely blanks out the signal from satellite. This effect is termed as Sun transit outage. It lasts for short periods each day for about 6 days around the equinoxes. Maximum outage time of 10 minutes being typical. The occurrence and duration of the Sun transit outage depends on the latitude of the Earth station, receiver location, location of the particular satellite, size or more specifically the beam width of the antenna, the apparent radius of the Sun as seen from the Earth, accuracy of alignment of the antenna direction towards the satellite. Most satellites launched today are initially placed on low Earth orbit